شباب, we will discuss a new topic, and it's a very important topic actually in our life, which is variable speed drives or variable frequency drives. And we are going to make the discussions on variable speed drives شباب in three main topics. One, regarding the modeling of electrical machines using reference frame theory. This is part one that we are going to discuss it inshallah today. The objective of this class شباب is to understand the meaning of reference frame theory and how we can make mathematical modeling of induction motor using reference frame theory, and why we need reference frame theory, or why we need to make modeling in different reference frames of induction motors. It's important to be used in control or controlling motor speed or torque or whatever. And this is inshallah the topics of today, or the objectives of today's class inshallah. Then in part 2 and 3 شباب, we will cover the different power electronic converters used in variable speed drives, okay, and how we can control it, how we can implement it. And finally inshallah there will be a last part in variable speed drives regarding how you can select your variable speed drive. And these are the main three topics inshallah, and we would like to cover it inshallah up to the end of our classes. So today inshallah we will focus on the modeling of induction drives using reference frame theory. First شباب, you know this is a well-known block diagram for electrical drive system. As you know, for any electrical drive شباب, there is a target all of time is to control the load, speed or torque, and in order to do that you have to sense some signals from electrical motor like volt, like current, like speed, like torque, like flux, and based on the sensing or the sensed parameters, there will be a feedback to a controller or a closed loop control for sure, and this controller or control theory will be implemented within a digital controller. Then this digital controller will provide some of pulses to a device called the power electronic converter, which will operate the motor at the desired values in order to achieve certain output for the mechanical load. So this is now the concept of any electrical drive system شباب. So we can say now the main component of any electrical drive systems are electrical motors, whatever DC or AC motors, feedback sensors that will sense some values like voltage, current, torque, and so on, digital controller like microcontrollers, microcomputers, FPGA, whatever the digital controller used, and the function of this device is to implement the theory of the control within the core of the digital controller, and to provide the proper pulses in order to operate the power electronic converter. So number 4 is the power electronic converter itself. For AC drives يا شباب, طبعا electrical motors are AC, and we are going to focus on induction motor. The different sensors will be used inshallah during our discussions, and the power electronic converter that will be used شباب is called back-to-back converter, which is nothing but rectifier to convert AC to DC, and after that inverter, which converts DC to AC again. So why we need to convert AC to DC, then converting again DC to AC? This is inshallah will be discussed in details in the next part, in part 2. Right. So for now, we are going to focus today شباب in the modeling of motor in the reference frame theory. So modeling of induction motor using reference frame theory. Firstly شباب, what is reference frame theory? It's very important to be recognized. No control now شباب for any type of AC motors using AC drives no control or all of control techniques or controllers are using reference frame theory. Right. We need to understand in details what the meaning of reference frame theory. First, the motor has a self and mutual inductances that depend on both stator and rotor currents. صح يا شباب؟ If we have now equations for stator and rotor current, there will be a relation between voltage and the current with the inductance. And for sure, you know that in induction motor, stator and rotor currents have different frequencies. So for instance, for stator current يا شباب, you have stator frequency which is F1. But for rotor current, you know F equals F2, which is S slip multiplied by F1. So for now, the parameters of the machine itself during operation will depend on each frequency. The reactance itself, X equals 2 by F multiplied by inductance. So in terms of stator reactance, it will be a function of F1. And for rotor reactance, it will be a function of F2. For that يا شباب, we used S in the equivalent circuit of induction motor. However, يا شباب, what we have discussed previously is called steady state model. Steady state approximated model of induction motor. It cannot be used يا شباب in practical life with this very simple model with a lot of assumptions. Okay, it cannot be used in a speed control or vector control of machines. However, the concept of control is right. You can use the concept of control what we have discussed previously in induction motor. We can use voltage over frequency control, we can add resistance, we can control frequency. All of these are possible. However, the detailed mathematical model of control is not based on the very simple model we have discussed in our classes. Okay, but it's only valid for a steady state. You can obtain or observe the performance of the machine at steady state using models what we have described previously. But in order to make accurate control technique or control system within AC drive, you have to use a more detailed model. Type. So for now, we agreed together that the value of reactance is frequency dependent. Is it okay, Shabab? Is there any problem in this idea? Good. Now, due to motor rotation, the reference frame theory is often used to simplify the mathematical model of induction motor. We have now, Shabab, 3-phase in stator, 3-phase in rotor, with mechanical phase shift, and due to rotation, we will have different electrical phase shift as well. So the model will be very complex. But what the reference frame theory can simplify or can give benefits here, let's see the idea. The idea of using reference frame theory is to refer the parameters to a frame that can be seen as constant value. So the advantages or why we use reference frame theory, Shabab, why reference frame theory is used to eliminate eliminates rotor position dependency. So the parameters will not be dependent of the rotor position, and this is very important. Okay, especially for inductances or capacitance. طبعا for induction motor we don't have capacitors, but if you have, for instance, self-excited induction generator, you have some capacitors. So you have to consider the value of capacitance or reactance or reactive capacitance or capacitive reactance, sorry, for the self-excited induction generator. So we have to consider the reference frame in order to eliminate the rotor position dependency. For that, the value of X will be constant, whatever the value or variable slip or variable speed. How? We will see. Also, it transforms nonlinear system to linear system for certain cases. which is already simplify the control operation and simplify the mathematical computations, شباب. Also, it can be used to make AC quantities become DC quantities. So instead of making AC component and complex number calculations, we will have only DC quantities or constant values, which is very easily can be used or can be computed using very small computation burdens and don't need any complex digital controller. So it will help a lot in simplifying mathematical coding, okay, and the use of digital controllers. Also, framework of the most controllers. Now يا شباب almost not most controllers, all of controllers now are using reference frame theory. So in order to control any type of machine, you need to understand the reference frame theory. So let's make some simplification to understand the meaning of reference frame theory. For instance, شباب, the rotating air gap flux is moving with the synchronous speed. You know, شباب, we have rotating flux in the air gap. This rotating flux is moving with synchronous speed. Therefore, if you assumed an object moving with the synchronous speed, this object will see the flux with a zero relative speed. Is it clear? Is this point clear, شباب?
Yes.
Right. If it is not clear for anybody, I can give an example or maybe visualize this example. Is it clear?
Yeah, I think it's clear because the flux speed will be the same as synchronous speed, so the relative speed will be zero.
Exactly. So what I mean, شباب, again, I will just draw simple graph here. If you have stator and you have inside rotor, okay, and the flux is moving here between stator and rotor with synchronous speed. If you have an observer moving with synchronous speed as well, so he will see the speed of flux is zero. صح يا شباب? This because the relative speed between the observer, which is the moving object, and the flux is zero because both of them are moving in the same speed. So the idea now, يا شباب, instead of standing at stator side here and observe the variables as a function of frequency and moving and varying, we can transfer our observer from stationary part to rotor or to synchronous speed. In this case, the variables will be constant, will not be variable. Is it right? Is it clear, شباب?
Yes.
أهم نقطة شباب. This is the most important point in understanding the reference frame theory. So, for instance, شباب, we have many frames now. We have stationary frame or stationary reference frame. In this frame, شباب, the observer is assumed to be on a stator frame, which has zero speed. So, if you are observing anything in the stator side, it will be constant. However, if you consider anything moving with synchronous speed or rotor speed, it will be variable. So this is the first frame, which is called stationary reference frame. There is another frame, شباب, called rotor reference frame. For rotor reference frame, the observer is assumed to be on the rotor frame. So, you know, the rotor is moving with speed nr. So if the observer is oriented on the rotor, in this case, we will see the rotor speed is zero. Is it right? صح يا شباب?
Yes.
Yes.
طيب, if the observer is on the rotor side, what is the flux speed that the observer can find here or can calculate?
The slip.
Slip, exactly, which is ns minus nr. So this is normal, which is the relative speed now, because the observer will be on the rotor frame, so he will see the flux moving with a speed of ns minus the frame, which is in r. So the speed of flux will be, at this case, will be the slip value in RPM. So this is now the reference, the rotor reference frame. The last reference frame is called the شباب synchronous reference frame, and these are the most well-known 3 reference frames used for induction motors. طبعا in synchronous motors شباب, we don't need rotor reference frame, because in synchronous motor all of parameters are function of the synchronous frequency or synchronous speed. So no need to use rotor reference frame in case of controlling synchronous motors. However, in case of controlling induction motor, you can use any of these 3 frames. Right. So synchronous frame شباب, where the observer is assumed to move with the synchronous speed. So if now we have observer يا شباب moving with synchronous speed, what will be the observed speed for rotor?
Would be in minus.
In minus, exactly, very good. So in this case, the observer will see the motor is moving in minus what? Huh? Minus is the sign, minus slip, exactly. So it will, the observer, if it is in synchronous speed, he will observe the rotor moving in minus s. Okay, minus s in RPM طبعا. Okay يا شباب, is it clear? طيب, let's see.
I have a question.
تفضل.
These 3 reference frame, we can deal with them as an options, or we should combine all of them to write a transient model for a motor?
It's not used like that. Let me give you an example. Now you are going to control the for instance the rotor current. So if you would like to in just one part of the controller, you need to control the rotor current or to observe the rotor current. So for now, you can see that rotor current is moving with frequency F2. Okay, so you can assume that you have a reference frame with the value of slip, even different to these 3 values. So you can make another frame with the frequency of slip only. And in this case, you just need to make transformation at a frequency of F2. This is special case. Let me discuss another case. If you observe or need to control, for instance, the rotor flux, around the conductor itself, okay, or the rotor speed, NR. In this case, you need to move your object or observer on rotor, because you will see the rotor speed is 0. تمام? Just in this part, in the part of rotor speed control. However, if you return in the same digital controller or in the same control technique, you need part of calculations related to synchronous speed, for instance, rotating flux. Okay, in this case, you can use synchronous reference frame. So we can use any frame within the same controller. It's not just one of the frames will be used at all. No, it's based on the part that you are going to apply your controller. Okay? What is the aim? The aim is to simplify the calculations. Okay? Is it clear now, Hisham?
Yeah, now it's clear. Thank
good.
you, Doctor.
Okay. The history يا شباب of reference frame theory or theorem, as you can see at 29, Barks transformation was invented, okay, and it was implemented on synchronous machine using rotor reference frame. طبعا synchronous machine is already the rotor is moving with synchronous speed. So whatever here rotor reference frame or synchronous reference frame, it's both are equal for synchronous machine. Another guy called Stanley at 1938, he made induction machine stationary reference frame. So this is another reference frame has been used already. Another reference frame, يا شباب, was someone called Cron. He made induction machine synchronous reference frame. So he used synchronous reference frame with induction motors. Another guy used induction motor rotor reference frame. But the most one used now in our life, which is arbitrary reference frame. It's made by Krauss at 1965. Yani this guy, he has a well-known book, okay? And by the way, yani, there are two professors, two Krauss professors, the father and the son, okay? And I was lucky that my professors, yani, who already taught me in Egypt, was yani, colleagues of the son, Krauss, the son, okay? And they yani, learned a lot from them, and already, yani, alhamdulillah, they give us a lot of knowledge from this guy. Yani, this is the most well-known book now, Shabab, used in all of control reference frames, okay? It's called Krauss, okay? And he made a reference frame called arbitrary reference frame. Arbitrary reference frame is very intelligent way. It will use any of these reference frames. Yani after that time, شباب, yani the theory of power, of machines, of power electronics, all of electrical power theories or theorem are based on the Krauss arbitrary reference frame used, because he can, or his model can be used in any other frame. Yani very simple way. And we will discuss it inshallah today. So firstly, Shabab, in order to understand the stationary and rotating reference frame, let's start from scratch. You know, the vector, Shabab, or the sine wave is nothing but a rotating vector. So if you have AC supply, V equal V maximum sine omega t, where V maximum is the big value of sine wave, okay, and omega is the frequency, omega t is the angle, okay, where frequency equal 2 times f times pi. So it's nothing but a vector, and this vector is rotating, as you can see, with the speed of omega. Okay, so this is the meaning of rotating vector. Now, if we have three-phase systems, three elements, R, L, and C, the passive elements of electricity. طبعا all of you يا شباب know the relation between voltage and current. So if we have V applied to resistive load, the current will be the same, moving with the same frequency, but just the magnitude will be reduced by the gain of 1 over R. Okay, or will be changed by the gain of 1 over R. So the waveforms of V and I will be in phase like that. In case of inductance or inductive load, you know the relation of between or the voltage relation on inductor. If we have L here and this is VL, so you know VL equals L di by dt. So in order to get the current, you just need to make this integration 1 over L integration V dt, which will be finally minus V maximum over omega L multiplied by cosine omega t. So you will find that the inductor current is lagging volt by 90 degrees. This is the one for pure inductive load. However, if you have inductive RL load, so the phase shift will be from 0 to 90 degrees, up to the values according to the value or ratio between R and XL. Similarly, for the capacitor, if we have capacitor, you know that I equals C dV by dt, the current of the capacitor equals C dV by dt, where V is the voltage across the capacitor. So the relation between voltage and current will be like that. You will find current is leading volt by 90 degrees. So now, Shabab, yani, this is if we take a photo at a certain instant, but when we consider voltage and current moving or rotating like that, so we have vector for current and vector for volt, and the sine wave is nothing but these two values are already rotating. So now for all of ST quantities يا شباب it's not constant. It's not constant value. As you can see instantaneously, if you have instant here, you can find that value is variable. And as you can see, at this time, شباب, t, you can find t, the current or the vector is moving up and down. So instantaneously, it's variable. However, it's nothing but a vector with constant magnitude, but it's rotating with time. Now, شباب, in order to recognize the magnitude, is it easy for you to just stay here and observe the value? Or you can go and start moving with the vector here and you can see the value, it will be constant. Is it right? And which is easier now in calculations?
The rotating frame.
Rotating. So if we moved with the rotating frame now, it will be very easy for you to make any calculations. So the idea, we need just to change the reference frame شباب to simplify the mathematical model of induction motor. This will be very helpful in control and computation. Because finally, شباب, you know, any computation in the control technique will be implemented in digital controller. So if the code is large, it will take a lot of memory. If the code is large also, it will take more time to be executed. And also, if the results are very huge numbers, it will need high memory and long time for calculations. So if you could simplify your computation, this will help you a lot to simplify the control model and also to simplify the coding on the digital controllers. So this is the aim now, why we need to use the reference frame theory. So if we now consider شباب, the vector diagram, so vector diagram for resistive load, you know, V and I are in phase. And the vector diagram for inductive load, you have IL lagging volt by 90 degrees, and for capacitive, it's leading by 90 degrees. So how we can observe phasor on the rotating frame? And this is what we have already could see here. As you can see, we have V and I is in red color, and V is in blue color. And as you can see here, in this case for instant, and let me just make stopping at any instant. طبعا يا شباب, here we have inductive load, which means I should be lagging V. صح? So V here is in red color, and I is in blue color, and it's lagging by 90 degrees because it's now considered as pure inductance. And you know, the normal direction of rotation is counterclockwise. So as you can see, the vector here, V, and this is the the vector V is in red, and I is in a blue in this way. Okay, شباب. So this is now the way of rotation of our vector. طيب. Let's represent together the three phases on the moving frame also. You know, for three phases, شباب, we have three voltages. Assume that VA, VB, and VC. VA at angle 0, for instance. So VB will be at angle minus 120, and VC will be at angle plus 120. So this is VAN, this is VBN, this is VCN. In order to make any mathematical model for three-phase system, you need to consider the three phases, and the three phases with a shift of 120 degrees. So, for instance, if we have a motor, and this motor have three phases like that, so we will have three sinusoidal supply. Can we represent these three phases in only two phases mathematically, just by considering one of the well-known transformation, which is called Clark transformation. So this is the first transformation. It's called alpha beta or Clark transformation. What Scalability transformation is making يا شباب exactly? We have now two perpendicular vectors. One is called alpha, and the other is called beta. And as you can see, there is 90 degrees shift between them. And all what we need is to represent or to object the three phases on these two vectors. Is it going to help? Shabab, what do you think? If we now converted three phase variables into just two phases, is it going to help?
Yes.
Yes.
It will reduce the variables. And if we have three variables, it will be two variables now. And also take care that in the AC 120 degrees phase shift, cosine and sine 120 is not zero. Is it right? So if you take cosine 120 or sine 120, it's not zero, شباب, صح? يعني not equal to zero. But here, if you already transform the quantities to alpha and beta, which has phase shift of 90 degrees, you have already cosine 90 equals 0. And also sine 90 equals 1. So it will simplify even for the mathematical variables. Yani if it is a function of cosine and sine, one of them will be eliminated and the other one will be constant. So it's very good, or we have large benefits if we just convert from three phase to two phase with phase shift of 90 degrees. It will help a lot. So let's see, شباب, what is the meaning of conversion? How we can make this conversion? Again, here we have our three phases. In this figure, شباب, we have two representations, not one. So let me just fix the orientation here in order to understand. Now you can see here we have phase A in blue color and phase, I'm sure other phases, B and C, okay? But if this is A, so this will be C in this case, and this is B. So A is in red color, شباب, B is in blue color, and C is in green color. So at any instant, شباب, you will find that the magnitude will be moving across A. This is A vector, and because the voltage is already changing with time, so the stationary frame of A itself will see the value moving. Is it right, شباب? But moving up and down, which is increasing in A direction or negative A direction, just in positive or negative. So let me again continue the operation. As you see, phase A, now it's negative. Now it will return again to positive and so on. The same is also for phase B and phase C. Okay, so this is now the rotation or the operation of the three phases now. Okay, for three phases, شباب, we have a theory called space vector modulation or space vector machine. Okay, this space vector, شباب, space vector theory transform the three phases into one magnitude. If you remember, when we calculated the rotating flux of the three-phase induction motor, we got that MMF equals 3/2 n I maximum cosine omega t minus theta. You remember, شباب? This is the relation what we already obtained. So now the MMF due to three phases could be converted to only one vector, which is representing the space vector. So this line, which is rotating now, representing the space vector of the three phases. So this is here considered as the three phases. Now let's convert these three phases into alpha beta. You will find that VA is moving across alpha like that. And VB will be analyzed across beta like that. And VC will be also, not B and C. And VA will be identical to phase A because it's in phase. However, beta, in terms of VA, it will be 0 all of time. So the component of VA objection on beta will be 0. However, value of B will be changed all of time. And there is a relation to convert B and C to beta. We will see the relations now. But finally, we will have two vectors now, alpha and beta. And the phase shift between them all of time is 90 degrees. And it can produce the same corresponding space vector. The same corresponding vector, شباب, here, which is rotating, is similar to the one here. So it has the same representation now, but just we converted 3-phase into 2-phase. So this can be implemented, شباب, using some mathematical equations. This is the transformation. This is called transformation or Clark transformation, which converts ABC to alpha beta. Just mathematical representation to object the 3 phases on alpha beta frame. طبعا gamma here will be the angle of 120 degrees. So finally, when you substitute here, you will find that we have 2 different shapes, شباب, of transformation. يعني it's not a big difference, because the only difference, as you can see here, will be in the constant here. This constant can be changed, and it will not affect any operation, because in any transformation, we will make transform and inverse transform again. So now you will multiply by 2/3, then finally you will divide by 2/3. So يعني whatever using this transformation or that transformation, يعني it's equivalent and it's right. However, sometimes you can see that this route will make some simplification in calculations, in some calculations, like in power calculations, for instance. So it's possible to use يعني any of these Clark transformation. طبعا يا شباب يعني how we could transfer again, يعني assume that we have here IA. So IA all of time will be in direction of alpha, and beta component will be 0. And at certain instant, if this is IB, so we can make now the combination, the objection of IB in alpha and minus beta. For IC, it will have 2 components, one in direction of alpha and one in beta direction. From this relationship, we can obtain this matrix or this transformation. Fine. Another transformation which is very important, and this is made in order to make the frame moving all of time, is called Bark transformation. So after obtaining the Clark transformation, شباب, which will convert the 3-phase into just 2-phase, alpha and beta, we need also to make another transformation in order to make this moving variable as constant. This is simply, شباب, if we assumed another or 2 other vectors like alpha and beta, but instead of having a stationary frame, it will be rotating frame. So if we assumed frame called DQ, like that, شباب, as you can see, we have here D and we have Q, and it's similar to alpha beta. However, DQ are not stationary frame. DQ will be a moving frame. Moving at which speed? With the speed of theta. Sorry, not speed of theta. Yani theta is displacement. Theta طبعا equals omega t. So with the speed of omega, where omega t equals theta. Okay, شباب. So if we made that, let me continue the emulation here. You will find that the values of vectors appeared as constant values. So this is now the advantage, شباب. We can convert the moving variable or AC variable into constant if we convert to DQ frame, which is called or made by Bark transformation. What is the speed now of theta? It can be in stationary reference frame. In this case, we can consider the angle or omega equals 0. It can be, شباب, in synchronous reference frame. In this case, we can consider omega as omega synchronous. And it can be also in rotor reference frame. And in this case, we can consider theta as omega r, which is rotor speed multiplied by t. So this is the way how we can convert variables from ABC to alpha beta, then from alpha beta to dq. So finally, if you just multiply the two transformations, Bark multiplied by Clark transformation, you can convert directly from ABC to dq. But it's not only dq, Shabab. We have also one other component called zero component. So it's dq zero. But zero component will be from its name, it's zero. It will be zero all of time if we have balanced three-phase systems. If we have unbalanced three-phase system, the zero component will have a certain value. But here, for electrical machines, we assume that electrical machines are balanced and symmetrical all of time, so we can consider only dq component, and and zero component will be zero. Here, Shabab, we have a small example, just AC circuit with three-phase supply. So this is a three-phase supply, A, B, and C, with phase shift 120 degrees and frequency omega E. And when you calculate the currents for each phase for the resistive for the inductive load, طبعا يا شباب, in order to calculate the current including a transient operation, you need to solve differential equation and give the summation of two solutions, okay, particular solution and homogeneous solution. So, or steady state and the transient. So the final equation of currents will be like that. Part depend on the exponential, which is due to transient, and the other part is due to steady state. So finally, this will be the three-phase currents, Shabab. We are not going to drive these in details, but this is just to understand the idea. So now, Shabab, the three-phase currents can be converted to QD or DQ components by the transformation we discussed previously, by multiplying first by Clark transformation, then by Bark transformation. Okay, we can get this Q and D component of current. Now, if you plot the I and V components in a stationary reference frame. Stationary reference frame, it means you can substitute at omega equal 0. So as you can see here, we substituted omega equal 0 in the equations we got previously. If you do that, you will find that VQ is moving sinusoidally like that. The same is also for IQ, and the same is for VD and ID, and there will be a phase shift of 90 degrees between Q and D component. If you would like to calculate the power, it will be finally at certain value, okay, like that, and it will be constant at steady state. This is in a stationary reference frame. Let's see together if we calculated the values in synchronous reference frame. You will find that VQ equals constant value at synchronous reference frame. IQ will have component at transient, and at steady state it will be constant. The same is also for VD and ID, and power as well. This is if we substitute by omega equals synchronous speed. So this is now, Shabab, regarding what is the benefit of applying reference frame now. We can simplify the computation by considering the values as constant. So now, Shabab, we considered this example for three-phase supply with synchronous frequency. However, if you have another system with different frequency, you can consider another frame, either synchronous or stationary frame. So we have something called the Shabab arbitrary reference frame. This is made by Krauss, and we will discuss it now. So let's discuss firstly the induction motor equations, Shabab. For induction motor equation, you have three-phase equations for stator winding and similar equations for rotor winding. And finally, you can get the psi, which is the machine flux, okay, for stator and for rotor in the three phases. Now, when we convert this using our transformation, okay, so this is now still in ABC frame, Shabab. Voltage in ABC of stator and rotor as a function of the current in ABC also for stator and rotor. And as you can see, it's a very complex matrix. And all of time, it will depend on value of theta, which is already variable. So this matrix is not easy, شباب, to be computed. However, if we consider applying Bark transformation on Bark after Clark transformation, so finally you can get just 4 equations instead of 6 at different frame. This is called arbitrary reference frame. Arbitrary, it means it can be rotated at any defined speed, and you can define your speed here. You have theta and you have omega. So based on the frequency you need, you can apply. We have also another equations here for stationary reference frame. As you can see here, we have here theta s. Here it became 0. Why? Because it's stationary. Okay, and so on, ya shabab. So this is stationary reference frame. Here, rotor reference frame and synchronous reference frame. And as you can see, a lot of parts of matrices equals to 0. Why? Because we made simplifications, ya shabab. These simplifications will allow to make calculations in a very easy way. How we can use this in control, ya shabab? There is a well-known control technique for induction motor, ya shabab, called the vector control or field-oriented control. It's basically depend on making analogy between AC motor and DC motors. You know, for DC motor, ya shabab, you have torque equals Kf multiplied by Ia multiplied by If, where Kf multiplied by If, we call it as machine constant multiplied by flux. Now, we can operate our induction motor like that, but this depends on make something like decoupling. How? By just converting the AC into 2 perpendicular components. How, shabab? Just by converting ABC to DQ. If we could make that, you will find that the torque equation of induction motor, if we operate it at synchronous reference frame, you will find that finally that torque equals K multiplied by ID multiplied by IQ. Sorry, this is capital letter. ID multiplied by IQ. Oh, sorry, both are small letters, ya shabab. طيب, what is ID and what's IQ? Now, ID, ya shabab, will be the torque component current. So, ID all of time, ya shabab, will represent torque. And IQ is the field component current. So, for now, ya shabab, this is considered as flux, and this is considered as torque current. So this is Ti, and this is psi I. In this case, shabab, in your controller, you can make decoupling. How? Just by making reference current, for instance, for IQ equals 0, or equals certain value. So in this case, you will control the flux and observe the required torque, for instance. Or you can control both, okay? So by this way, shabab, we could convert the complex induction motor to a very simple DC motor control. So the representation, shabab, in the control itself, we will need reference values for ID and IQ, for torque and flux. And by using transformation, we can obtain the required ABC currents, which will be applied to the inverter. How? This, inshallah, will be discussed in the next class. And finally, the motor output, this is now the inverter with the motor, shabab. So, or even the current of the inverter, it will be applied to the machine itself. So inside the machine itself, we will need also some other transformations to make the control in order to make ID and IQ moving all of time with synchronous frame. So this is the way, shabab, or how we can use reference frames or transformation inside controllers. We need sometimes to make it before of the inverter control, and sometimes to observe or calculate some variables within machine itself. So we can use many techniques or many transformations within the machine according to the needed control. This is, shabab, by the way, called vector control implementation. We have 2 different types of vector control implementation using direct field orientation, just by giving directly ID and IQ as values. Okay, and we can obtain ID and IQ in indirect way by means of flux and torque. So, both of techniques can be used, and both of them are called field-oriented control technique. This is a vector control يا شباب. Some other control techniques are also used, like direct torque control, but it's different a bit. It depends on space vector modulation. Inshallah, we will discuss this part يعني inshallah in next class. Okay. يعني however يعني there is no time to discuss it here in our class. So today شباب, as a summary, we understood what is the aim of using reference frame, why we need to use reference frame. We need to use it in order to simplify our computation. And as you could see, you will need the transformation before of the conversion in order to control the inverter itself, and during observing or obtaining some variables within the machine model itself. So you will need many times transformation within your model. Okay, شباب? So this is the way how we can use the reference frame theory شباب in order to make mathematical modeling for electrical motor. So يعني we have finally 4 different frames. 3 are well known: synchronous, rotor, and stationary frame. And the first one, arbitrary reference frame, which is made by Krauss. This is general for any defined frequency if you need to apply any type of control technique. يعني I wish يعني this class شباب to be clear. I know it's not that easy and يعني new concept for you, but it's very important شباب in electrical drive and يعني variable speed drive applications. Any questions شباب?
Yeah, Doctor, could you please go to the block diagram slide?
One?
Yes, there is a DQE to DQS. What is the meaning of this?
Okay, DQE here, this is DQE to DQS. This is from synchronous, okay, to stationary frame. يعني firstly, these values are given in synchronous reference frame. So you need to convert it firstly to stationary frame. Then يعني we can consider this part as from DQ to alpha beta, and then from alpha beta to IABC. You got it? يعني we said in order to make transformation you need two steps. One from ABC to alpha beta, then from alpha beta to DQ. Okay?
Okay, yes.
So here we just transform it firstly from DQ because we have reference as D and DQ. Because you can give ID reference or IQ reference because it will be constant value. Yeah, you can say for instance ID reference equals 5 ampere, not a function of sign. Okay, and the same is also for IQ, for instance. So this will be converted to rotating frame. Okay, sorry, from rotating frame to stationary frame on alpha beta. Then you can convert from alpha beta to IABC in order to use it in the inverter. Okay, because in inverter, yani we will need the modulation for some control techniques like sinusoidal pulse width modulation. We need modulation waveform, and modulation waveform is given as A, B, and C waveforms. تمام? This is one way. Some other techniques are depending only on DQ. Yani we don't need these parts, which is based on space vector. Okay, and space vector will take the value of VD and VQ and just convert it to space vector directly. So this is another way. So it's up to our control technique we are going to implement. But here, field-oriented control or vector control are a function of the ABC variables. So we need to make both of transformations. And here, the same. We have ABC, and we need to convert firstly from ABC to alpha beta, then from alpha beta to DQ. Okay?
Yes. Doctor, how we change the reference ABC to pulses?
How we can convert the reference ABC to pulses, this is what we are going, inshallah, to discuss it in details in next class, which is the sinusoidal pulse solution technique itself, how we can make it and implement it. And inshallah, we can see it also on MATLAB, how we can implement PWM on MATLAB simulation.
Okay.
Any other questions, Shabab? Everything is clear, alhamdulillah? Okay, thank you very much and see you inshallah next class. السلام عليكم ورحمة الله وبركاته.
عليكم السلام.